this much lifetime with 99% reliability. I have to convert these numbers into the catalog standards. And the catalog standards talk about 1 million cycles because that's the standardized rating, right? And the catalog always rate everything with 90% reliability. Okay? That's essentially the problem where we just did. I want something that survived 1800 newtons, 720 million cycles, 99% reliability. I have to convert this number into the catalog numbers, and this is the formula to do it. This is what I want, 570 million revolution, 400 pounds load. I have to find what the catalog is. The catalog rates everything in 1 million. So I find that with this formula. But this is assuming 90% reliability. Now we are changing the reliability variable, and if you need something with 99% reliability, the formula is different. And this is the reliability. And we find that the answer is 32.8 kilometers. So you find this number, that bearing will do this. Okay, is that clear for everyone?
Yes, sir.
Okay, good.
Sir?
Yes.
And just confirm, revolution the same as cycles, right?
Yes, revolution is the same. By the way, reliability of 99%, meaning it's all statistics, right? When I say I want my bearing at this load to survive 720 million cycles with 99% reliability, means that 1 out of 100 will not reach 720. There is no such thing as 100% reliability, right? Nothing. So we always pick statistics, what's good enough for you. And I say, well, you know, if 1 out of 100 does not meet my spec, I'm fine with that. So that means 99% reliability. When the bearing manufacturers say, this bearing that you paid, C10 of 32 kilonewton, will survive 1 million cycles, they are saying that statement with a 90% confidence level. Meaning that I guarantee you 9 out of 10 of that type of bearing that you buy, only 9 of them will survive 1 million cycle. Are you fine with that? So that's the statement. But because I want something with 99% reliability, I cannot load it 32,000. I can only load it 1,800. That's just it. I'm just turning the sentences around to give you that understanding. Okay? Now, let's do a problem combining the axial and radial load. So, on top of this, now we are going to do a problem with axial and radial loading. By the way, a catalog looks like this, right? This is a sample catalog. This is the bore diameter, the outer diameter, etc. And you see the load rating, there is C10, there is C0. So we are going to now combine axial and radial load. The question is, if you have a bearing and then you have an axial load FA and you have a radial load FR, which one do you put as FB? The answer is It's not as simple as it is. Okay, so we're going to do a procedure to combine FA and FR in order to put it as FE. Because the FD that we talked about has always been radial only. Once you have axial load, then things are going to change a little bit. Okay, so let's do this. Yeah, this one. Okay. So we are given a situation with axial load FA of 400 pounds and radial load FR 500 pounds. Okay, everybody read the problem, right? FA, FR. We have an outer ring stationary, so inner ring rotation. And this is going to influence our calculation. Outer ring stationary means the inner ring rotates, the outer stationary. The basic static load rating C0 and the C10 is, okay? Estimate the life L10, and we'll talk about what L10 is, at the speed of 720 RPM is the question. So now we're switching things around and find the lifetime instead of select bearing. First, we need to combine FA and FR. So combining axial and radial load has a procedure in itself. So we have to do this before we do anything else. The first step, you calculate FA divided by CO to look up this parameter E on a table. Okay? So we have a table to combine axial and radial load. And in order to use this table, we're going to first calculate E. Because you have FA divided by CO, and then E, and then this is what you look up. Okay? So that's the first step. FA divided by CO. Apparently, this combination of axial load depends on your static load rating. Okay? So we are going to interpolate E. Okay, so FA divided by CO is 0.09. So we are landing in between this table, because this is between 0.084 and 0.11, right? We are somewhere between here. So what is the E? It's called interpolation. Interpolate. Anybody remember interpolation? No? Never learned that? Okay, interpolation is basically, if I have 2 points, what about this guy? Right? If I know this and this, what would be here in the chart? That's interpolation. Okay? So, This is my E. This is my FA divided by CO. And step number 2 is to calculate FA divided by PFR, compare with E. I'm trying to write this in a step-by-step fashion for ease of understanding. This ratio gives you the sense of how much axial compared to radial, right? Here, you are comparing the axial load with the static load rating. Here, we're comparing the axial load and the radial load. How dominant is the axial load in comparison to the radial load? Okay, in this formula, V is equal to 1 for inner ring rotation. And for outer ring rotation, it's 1.2. Outer ring rotation. What kind of situation will be an outer ring rotation? Can you give me an example? Sure. Yeah. The axle stationary and the outer ring rotates. An inner ring rotation is anything with a shaft rotating. Okay? So, FA divided by PFR is 0.8, and this is greater than E. If it is greater than E, you look up a different column. Okay? So now we are ready to use this. This is my FA divided by CO, right in between this row. And then, depending on my FA divided by PFR, whether that's less than or equal to E, or if it's greater than E, then I either use these values or these values. So the third step will be to refer to the table to determine X1, Y1, or X2, Y2 to calculate FE. FE is the equivalent load. FE is the combination of axial and radial load. I know it's a long journey. So, because we are greater than E, we are here. Right? We are here. And we are here. So, because we know where we are, therefore X2 is 0.56 and Y2 is 1.527, and this is the result of a further interpolation. Because we are between these two values, right? That makes sense?
Yes.
Yeah? So Y2 is interpolated. And using these values then, I can calculate my FE. FE is X2 VFR plus Y2 FA. This is 0.56 times 1 times 500 pounds plus 1.527 times 400 equal 891 pounds. So, you have a combination of 400 pounds here and 500 pounds here. the equivalent load for these two loads is not 900, okay? You do not ignore 400 and just take 500. You have to combine them into FE whenever you have a combination of axial and radial. And the process to combine them, sorry to say, is a bit involved. Okay? You have 3 steps. Calculate FA over CO. I'm here. I need E in order to do this comparison. Right? So I'm going to interpolate E. Calculate this guy. Be careful. V is different if it's an outer ring rotation. Compare with E. And because I know it's greater than, I'm here on these two columns. Pick my x2 and y2 from the table, interpolate when necessary, and finally we have one important observation. Look at these two columns. What does that tell you? Y1 is all zeros, right? So, if this is less than E, what happens to this formula? Replace the x2 and y2 with x1 and y1. What will happen to this formula? And y is multiplied with? Y2 is 0, multiplied with the axial load. So the equivalent load, therefore, is not influenced by the axial load. Okay, so when we end up with these columns, essentially what we're saying is that the axial load is not consequential. Okay, got that? So what we are doing in a bigger picture, okay, you might get lost in the math, but essentially what we're doing when we compare this parameter with these is we are trying to judge, you know, is the axial component significant enough for me to include it, right? Because y2 is multiplied with FA. Therefore, these constants, these numbers, gives you a significance level of how much axial is going to influence my lifetime. Okay? So, there are these two kinds of load. Radial is the majority, and FA, how much it influences, will depend on this combination. Alright, we're not even doing the problem yet. We're still preparing
Sir.
the equivalent load. Yes?
Can you go over again how you interpolate y2, sir?
Oh,
Are you formula?
you want me to go through interpolation formula?
Then y2.
Okay, I'll leave that to you to figure out. Look at this. When I want to interpolate E between 0.28 and 0.3, notice what I do. Okay? What I did is 0.3 minus 0.28, this minus that, divided by 0.11 minus 0.084, okay, multiplied by the difference between my interpolation parameter minus this value. Okay? So if you have 2 points, A comma B, C comma D, I'm trying to get to the middle. Okay? Let's figure that out. Because it's a bit involved if I explain that. I want to finish the problem. Okay, now we are ready to do, okay, this is from the previous problem, yeah. Lifetime calculation. I would like to remind you that this we are doing with a C10 assumption, which is a 90% survivability. Okay? So L10 refers to 10% failure, which means this is 90% reliability. Reliability. Therefore, we are going to use this formula. Okay, not the one with the Weigel distribution. We are going to use the simpler formula. Or if I rearrange this, LD, which is the design lifetime, is LR times FR over FDA. And FR is really C10, right? So LD, which is my design lifetime, will be 10 to the 6 C10 divided by FE in replacement FE basically replaces FD. Okay? And so this really is the calculation for number of cycles. What is C10? Okay. What is FE? 891. And A is 3. By the way, this is just an algebraic manipulation. I power both sides by 8. Do you need me to explain that? No? Okay. So, my LD is 697 times 10 to the 6 cycles. But, I need it in hours. Okay? This squiggly L is lifetime in hours. We are given the RPM. So at 720 RPM, what is the lifetime in hours? How do I do this? So I have 697 times 10 to the 6 revolutions, cycles, right? I want it in hours. So, do I multiply or do I divide? Okay, this is RPM. RPM is revolution per minute. I want minute, not revolution. I want time instead of revolution, right? So, 1 minute, in 1 minute, there are 720 revolutions. That's how I do unit conversion. And that kind of keeps you organized. But I want it in hours. So, I want minute in the bottom, right? Hours on the top. 1 hour, 60 minutes. So therefore, I will survive 16,135 hours, approximately. I mean, it's not going to snap at 16,136 hours, right? Because these are statistics. And we are using this formula because it's a 90% reliability. Questions? Okay? No questions? Anybody get confused on the LD and L10 thing? Alright. Let's see. Have I discussed everything that needs to be discussed? Preloading. Preloading basically removes this clearance. This is exaggerated, by the way. But sometimes you do bearing preloading to remove internal clearance and increase the fatigue life. Basically, when you fasten it, you are creating a certain load on the balls to make sure all the clearance is taken up. So it's not like shaking. Okay? These are some load application factor. Remember, we talked about load factors, and it's kind of 10% extra, 20% extra, depending on the applications. So this is kind of a bearing life recommendation for different types of machineries in terms of tens of thousands of hours. We talk about bearing lubrication. There is grease and there is oil. You use grease when speed is low, low temperature. You will need protection when you need protection from foreign matters, because it's just more or less, it's harder to be squished out. When you want simple bearing enclosures, because if you use oil, then it has to be an open bearing and you have churning oil all over. So you need the casing. Speeds are high, temperatures are high, then you need the casing to have oil-tight seals. It's kind of annoying to use oil lubrication unless you are in a transmission setting. Okay? I would say in most cases you're gonna use remodeling. This is called a pillow block. It's just a bearing on a block. Okay, this is an example of duplexing with tapered roller bearing. Or angular contact bearing. You also need duplexing because then you'll have the axial reaction. Okay? That should be it for bearings. Questions? Anything that I have not covered? You're gonna do the Google form again for the second time, and this one is going to be graded. Go ahead and start the Google form for the post-test.
Bisa pakai link yang sama kan, Sir? Pakai link yang sama buat post saja. Pakai link yang sama.
Yeah, the same one.
Masa-masa sama dia iya sama aku jauh sebenarnya kalau buat ini nanti sambil dengerin itu tawarin hatinya apa lo bikin sendiri iya, Bang Mister Ini kapal gimana sih?
Iya pakai gua loh, bro.
Lu diranja pasang larang berapa? Maret tengah gua kelarin sekarang dulu. Iya. Lu mulai puasa ikut aku beres ikut sama dia ya setengah jam aja.
Puasanya
Lebih parah dari Syiah lama-lama.
Kita nggak masuk dulu.
Jadi dia apa?
Okay, you guys get the uniform?
Yes.
Okay, you guys
Bong. Lu Rabu-abu atau Jumatan hari ini? Kemarin Rabu-abu atau hari ini Jumatan?
Siang.
Oh, makan siang. Udah balik ke
Memang kayak begitu.
Dia ngomong kalau nanti malam ke bank sekarang jangan yang mahal-mahal. Hai gila. Kemarin pernah gua, lu duduk mana?
Mindset.
Gua di bawah tapi sebelah kanan. Gua sebelah
Oh, gue di sebelah kiri.
ke sono.
Kenapa?
Lu nanti ini apa?
Master.
Thank you.
Hey, yo, man.
Aiman,
Yeah.
for iftar. For iftar.
Yeah, but I'm not gonna carry it around. I'm gonna be hungry.
No.
Banyak kurang anjing.
Betul.
Pineapple cake something. Cookies. Ya, dia emang tahu nastar. You try it now.
Orang lagi puasa bohong.
Siapa? Dua lagi. Justin udah belum?
Gua belum.
Gua belum.
Tolong sebelum. Thank you.
Bagi dua. Ambil yang punya Aiman.
Ambil dari tangannya yang punya Aiman.
Jel, jadi kalian gimana?
Atau itu lu mana sekarang?
Udah mau as aja.
Yang mana?
Yang katelan itu loh.
Oh, kan like that.
Kan like that.
Itu berapa?
Gak beli.
Oh, kan like that.
Oh, yang mana bayar, yang lu gratisnya kan?
Aduh, anjing. Kan like that.